In this lesson, we are going to talk about how to find the equation of a line given 2 points. So, in the previous lessons we said, the equation of a line is given by y is equals to mx plus b, where m represents the gradient of the line and b is the y-intercept. Then this y are the y coordinates, the ones we are given, and x are the x coordinates, the ones we are given. So, to get the gradient, m is given by change in y divided by change in x. And if you don't know what is change in y divided by change in x, you can review lesson 2 after this concept there. And then the y-intercept, if you don't know what is the y-intercept, you can review lesson 3 after it there. So, once you know the gradient and the y-intercept, becomes easy to know the equation of the line. So, once we have those two, the equation of the line can be given by this. Y minus y1 is equals to m into x minus x1. But also, it can also be given by this. Y minus y2 is equals to m, which is the gradient, into x minus x2. But I want to show you where these x1, y1, y2, x2 are coming from. So, go with me. Let's say, for example, we have a line like this one. This line passes through the points 2, 3, and we can also pick another point like 7, 8. Passes through the lines points 2, 3, and 7, 8. So in this case, if I can say line passes through point A, which is 2, 3, and point B, which is 7, 8, then this becomes x1, this becomes y1, this becomes x2, and this becomes y2. So to get the gradient of this line, I need to take m, which is equals to y2, which is 8, minus y1, which is 3, divided by x2, which is 7, minus x1, which is 2, and becomes 8 minus 3, which is 5, divided by 7 minus 2, which is also 5, and the answer becomes 1. So now that I know the gradient, I can also find the y-intercept. To find the y-intercept, I can apply either of these equations. Let's start with the first one. The first one, this y1, we already have it here, and this x1, we already have it here. So, if I take them, I say y minus y1, which is 3, is equals to m, which is the gradient that we already have, which is 1, into x minus x1, which I already have, and it is 2. Then I get y is equals to, once you open brackets here, you still have x minus 2, because 1 multiplied by x is x, and 1 multiplied by 2 is 2. And then you take this 3 on the other side, and it becomes plus 3. So the answer becomes y is equals to x minus 2 plus 3 is plus 1. So, if you check well, you realize this line has taken, this equation has taken the form y is equals to mx plus b, where m is the gradient and it is 1. That's why we did not put a 1 here, because anyway, if the unit is 1, we don't need to put it here. And the y-intercept b is also 1. You can try this with the values of b, but now you apply the second formula. Now y2 becomes 8 and x2 becomes 7, and you see if you get the same equation like the one here. Can we try another example? This question 1. Find the equation of a line passing through A, which is 1, 2, A, which is 1, 2, then B, which is 5, 10. So, the form of the equation, of course, is y is equals to mx plus b, where b is the y-intercept and m is the gradient. So in this case, I will start by finding the gradient, which is given by changing y divided by changing x. And here, our x1 is this one, y1 is this one, x2 is this one, and y2 is this one. So, if I replace them here, y2 becomes 10 minus y1, which is 2, divided by x2, which is 5, minus x1, minus x1, which is 1, and becomes 8 over 4, which is 2. And divided by 4 is 2. So the gradient is 2. Then, I replace the values in the equation. Y minus y1 is equals to m into x minus x1. But we already have this x1, we already have the gradient, and we already have y1. So it becomes y minus, what is y1? It's 2. Is equals to 2, because 2 is the gradient here, into x minus x1, and x1 is 1. So it becomes y minus 2 is equals to 2x minus 2, which becomes y is equals to 2x. This one, and then I'll take these 2 on the other side, which becomes minus 2 plus 2, then it becomes y is equals to 2x plus 0. So in this case, the y-intercept is 0, and this is the equation of the line. Sorry, I forgot to tell you, here it is plus 0, not minus 0. Then, can we try to enter the values of this line in our interactive graph so that we can see if we get the same equation? So the values were 1 for x1 and 2 for y1, then 5 for x2 and 10 for y2. Then we plot the line, and as you can see, y is equals to 2x plus 0. So in this case, the y-intercept is 0. And for sure, if you check here, this line, it passes through 0, where it cuts the y-axis at 0 when x is also 0. In short, it passes through the origin. Can we try another example? Here we have 2 points, one C, which passes through negative 2 and 3, and the other one is D, which passes through 4 and negative 3. So in this case, of course, our equation of straight line is given by y is equals to mx plus b. So I start with finding m, which is given by changing y, by changing x, and we already have all these values where we have this is x1, this is y1, this is x2, this is y2. So I can replace them here and say y2 is negative 3, then minus what is y1? y1 is 3 divided by x2, where x2 is 4, and now minus x1, which is negative 2, like that. So I get minus 3, which is negative 6, divided by minus 4 minus 2 is 6. So the gradient becomes negative 6 divided by 6, which is negative 1. Then we apply our formula here, which is y minus y1 is equals to m into x minus x1, like that. And we already know our y1 is 3, then is equals to m, which we already know it's negative 1, into x minus x1, and our x1 is negative 2. Negative 2, like that. So you can put it like this. So y minus 3 is equals to negative x in brackets, but you see here I had a negative, and then this is also a negative, so it becomes a positive, so it will be plus 2, but again outside the brackets we had negative 1, so now that positive again multiplied by negative 1, it again becomes negative 2. So then it becomes now y is equals negative x minus 2. Then I take this on the other side, which is minus 2 plus 3, which now becomes positive 1. So you see, we have got our intercept is positive 1 and our gradient is negative 1. Can we try to enter the values of this equation here? I will see if we get the same results. So it was negative 2 for x1 and 3 for y1, then 4 for x2 and negative 3 for y2. Then once we plot the line, we can see the line is here, and the equation is y is equals to negative 1x plus 1. Can you try question 3? Can you confirm if you got these results? Let's enter these values in our graph and we see the equation of this line. So it is 0, negative 1, 0, negative 1, then 8, 3, 8, 3, and 8. Plot the line. Did you get the equation like this, which is y is equals to 3, x minus 1, where negative 1 is the y-intercept and 3 is the gradient.